Synchron is the first to reach full human trials. They initially began testing in Australia with a group of 4 patients receiving their BCI implant. Apparently, Australia has looser regulations about what you can put into people's brains. And just last year, Synchron was given the go-ahead by the FDA to commence human testing in the United States. The first U.S. patient just received their Stentrode implant and will be the first of 6 people involved in the $10 million study funded by the National Institutes of Health. To understand why Synchron crossed the threshold before Neuralink, we can look at the design of their implant. The Stentrode is named after a common medical device called a stent. This is just a long, thin, flexible tube that doctors can insert into a patient's blood vessel. Stents are used all the time for a number of procedures, mostly involving the heart. If you have a blocked or narrowed artery, the doctor will insert a stent tube to hold it open for you so that blood can flow and you don't have a heart attack. So, the Stentrode is actually what it sounds like, a stent combined with a cluster of electrodes. The Synchron procedure is to insert the stent with a catheter into the patient's jugular vein and run it all the way up into a blood vessel that is nestled within the motor cortex of the brain. When they pull back the catheter tube, the hollow wire mesh of the Stentrode will expand out and interface with the walls of the blood vessel. And the wire at the other end of the Stentrode is connected into a very small computer device that is implanted inside the patient's chest cavity. If this sounds at all familiar, that's just because this is virtually the exact same procedure as implanting a pacemaker. They're just running the wire into the brain instead of into the heart. The implanted computer device will then connect with the rest of the system via Bluetooth, either paired to a computer or